Hey guys, I'm gonna go ahead and do number 2 on the orbital mechanics practice. I got a few emails about this one, so let's go ahead and tackle this. Okay, so it reads, the period of the moon is approximately 27.2 days. This is 2.35 times 10 to the 6 seconds. Determine the radius of the moon's orbit and the orbital speed of the moon. We were also given the mass of the Earth, which is 5.972 times 10 to the 24th kilograms. Okay, so since I didn't give a lot of space right here, I'm just going to do it right here. All right, so if you see me going back and forth, I apologize, but this is kind of the best space for it because, you know, Mr. Mitchell's handwriting is absolutely atrocious, so I'm going to need a lot of space. Okay, so this is what we want to find, A and B, the radius of the moon. Actually, let's be a little bit more specific. Determine the radius of the moon's orbit. Okay, radius of moon's orbit. Okay, and the orbital speed. Now, what were we given? I'm gonna write down our givens over here. We were given number 1, the period. All right, and the period is big T. There goes my pen again. Big T is 2.35 times 10 to the 6th seconds. We were also given the mass of the Earth. Now, the mass of the Earth is the central mass, and I'll call it m cent, because when we did those, the guided notes, like right before we left school, I called everything like the central mass. Just know that the mass of the Earth is the central mass in this case because the moon is actually orbiting the Earth. All right, and our mass, that's supposed to be an equal sign, is 5.98 times 10 to the 24th, and this is in kilograms. All right, so there we go. First things first, radius of the moon's orbit. Now, if you take a look at the equations from your guys' guided notes, there they are. Those are the 3 equations that we derived. Okay, now, we're going to need this one later, obviously for the orbital speed. Okay, but we're not doing that yet. This guy right here is the one that we want to use. Okay, we're not going to use this acceleration equation because guess what? We don't have acceleration. Okay, could we solve for acceleration? Yeah, maybe, but let's not go over too many steps. Let's just hit this equation up. This is Kepler's third law. And if we can rearrange this equation in order to solve for r, we're good to go because we have everything here. We have the period. We always have big G, and we have that central mass. Right? And obviously that's pi up here, which is 3.14. Or you can just use, obviously, the pi symbol in your guys' calculator. So we're good to go. So let's go ahead and utilize that equation. And I'm going to rewrite it for you, so don't worry. All right. Let's do the actual problem in a different color. Let's go green. Okay, so I'm going to write down the equation first. So t squared over r cubed is equal to 4 pi squared divided by big G times the central mass. All right, there we go. All right, now rearranging this. You could go about this a few different ways. I guess I can just do it for you guys if you'd like. What I would do is multiply by r cubed. Multiply by r cubed. Okay, so my r cubed goes away. Now my r cubed's right here in the numerator. I like that better. Just me personally, starting it off that way. Like I said, algebraically, you can tackle this so many different ways. Okay, so now we have t squared is equal to 4 pi squared. Let me do this more. I forgot I could do this. There we go. Times r cubed. Okay, divided by big G times the central mass. All right. Now, what we can do here is multiply by G times the central mass. Boom, that cancels out. What you do to one side, you got to do to the other. M cent. Okay. Now we have t squared times g times the central mass is equal to 4 pi squared times r cubed. Now, all we got to do is divide by, gosh, I need to do this better. There we go. Divide by 4 pi squared. What you do to one side, do the other. 4 pi squared. Okay, so those cancel out. And now we're left with, and I'm just going to rewrite this, r cubed is equal to t squared times big G times the central mass all over 4 pi squared. All right. Now, I'm gonna leave it as r cubed, and then we'll just kind of take the cube root at the end when we're solving this officially. All right. So at this point, let's plug in our values. Okay. So remember, our t is 2.35 times 10 to the 6, and we're gonna go ahead and square that. Okay. This is gonna be multiplied by big G, which is a constant value of 6.673 times 10 to the negative 11th. Now, I'm not going to put the units in here. You guys can figure that out afterwards. All right. And then the central mass is going to be 5.98 times 10 to the 24th. All right. And this is all divided by that line. There we go. Nice. 4 pi squared. All right. Now, you can, like I said, you can use 3.14, or you can just plug in the symbol in your calculator. Now, when calculating these on your calculator, remember I told you guys to break up your guys' calculations. So start with 2.35 times 10 to the 6, square it, press enter, then multiply by 6.673 times 10 to the negative 11th, press enter, and so forth. If you break up your calculations, you're not going to make a mistake. Okay? We don't want these stupid calculator errors. We don't want that. All right? Okay. Now, remember, this is not equal to r. This is equal to r cubed. All right? So, r cubed is equal to, and then let's plug it in, calculator. I'll let you do that on your own. You should get a value of 5.58. That's 5.58 times 10 to the 25th, and this comes out to be meters cubed. Meters cubed. All right. So in order to solve, take the cube root. And r comes out to be 3.82 times 10 to the 8th meters. That's your final answer. All right. Now, the last thing we need to do, and maybe hopefully I'll have room right here. I'm going to do this. A little space for the last one, because we're not going to need a lot of space. Okay. We're going to find the orbital speed. Okay, to find the orbital speed, v is equal to the square root of big G times the central mass all over r. All right, so now that we have r, we can solve. Okay, so v is going to be equal to square root, let's plug in our values, 6.673 times 10 to the negative 11th, okay, I'm put parentheses, times the central mass, which is 5.98 times 10 to the 24th, and this is all over the radius, and the radius is 3.82 times 10 to the 8th. All right, when you do that, let me do that on my calculator because I wasn't prepared. If it comes out to be, I get velocity is 1.02 times 10 to the 3rd meters per second. All right, and let's do this. So I'll highlight our answers. Our first answer, 3.82 times 10 to the 8 meters, and our second answer is 1.02 times 10 to the 3rd meters per second. Okay, and if you have any questions on this, please message me via Canvas. Thanks, guys.